Hello everyone. Welcome to SWAM online lecture series on the topic database management system. I am Mohammad Bukhari, working as a professor in the Department of Computer Science at Aligarh Muslim University, Aligarh. I am pleased to have you join me today in this lecture. I will discuss few interesting topics including functional dependencies, multivalued and joint dependencies. So let's begin the journey of the today's lecture. In the last lecture, we have discussed normalization forms and database management system. Before proceeding with today's lecture in detail, let me discuss the answer of the question that I had given you in the last lecture. The first question was explain the different normal form in normalization. The answer is normalization in database management system ensure efficient data organization by eliminating redundancy and dependency issues. First normal form ensure atomicity by removing repeating groups. Second normal form eliminates partial dependencies, ensuring all key attributes depends on the primary key. Third normal form defines further by removing transitive dependencies, ensuring non-key attributes depends only on the primary key. Basic code normal form enforce strict rules, ensuring all dependencies are on the candidate key. Each normal form build upon the last, progressively progressively refining the database structure and enhancing data integrity, reliability, and efficiency. The next question was, what are the primary goals of normalization? Normalization in database management system aims to achieve three primary goals. Firstly, it reduces redundancy by organizing data efficiency. By organizing data efficiently, ensuring each piece of information is stored in only one place, minimizing data duplication. Secondly, normalization minimizes the risk of data anomalies such as insertion, deletion, and updation anomalies by structuring data to eliminate dependencies issue. Lastly, it enhances data integrity by enforcing consistency and accuracy, ensuring that database remains reliable and maintain its integrity over time. By achieving these goals, normalization optimizes database performance, facilitates data management, and enhances overall system reliability. The third question was describe the step involved in normalizing a table to comply with first, second, and third norm form. The answer is normalizing a table to comply with first, second, and third normal form is systematic process in database management system. Firstly, for first normal form, are defined repeating groups or ensuring atomicity by breaking them down into separate rows. Secondly, for second normal form, analyze the table's functional dependencies and eliminates partial dependencies by decomposing the table or creating separate tables for related data. Thirdly, for 3NF, examine for transitive dependencies and remove them by splitting tables, further ensuring that non-key attributes depend solely on the primary key. These steps iteratively defines the table's structure, reducing redundancy and dependencies issues while enhancing data integrity and efficiency. The last question was, what is the basic code normal form and why is it important in database normalization? The answer is basic code normal form is an enhanced version of third normal form in database normalization. It ensures that every determinant in a table is a candidate key, meaning to non-prime key attributes is functionally dependent on any proper subset of any candidate key. BSNF eliminates all types of anomalies and redundancies, enhancing data integrity and consistency. It, it is important, its importance lies in its ability to ensure that the database schema is free from all possible update, insertion, and deletion anomalies, thus facilitating the efficient data storage, retrieval, and maintenance in the database management system. So let's begin the agenda of the today's lecture, which is to discuss the following topics you can see on the screen. First topic is functional dependencies, multi-value dependencies, joint dependencies. Functional dependencies. Functional dependencies in database management system are constraints that define the relationship between the attributes within a relational database. They establish rules regarding how the value of certain attributes determine the value of other within the table. In a relational database, we can say a functional dependency is a constraint between two sets of attributes in a relation. For example, if we have a certain rule, if we have a relation R with a two set of attributes A and B, we say that B is functionally dependent on A, denoted as A arrow B. If and only if each value of A in R uniquely determines the corresponding value of B. Let's take another example. Consider relation R with attributes, it means columns A, B, and C. If for every combination of value of A, there is only one corresponding value of B, we say that B is functionally dependent on A determines B. Similarly, if A determines both B and C, we can express this A determines B and A determines C. These dependencies are fundamental in ensuring data integrity and consistency, as they hold prevent anomalies such as insertion, deletion, updation anomalies. By identifying and understanding these dependencies, data designer can efficiently structure tables, optimize query performance, and ensure that the database schema is normalized to minimize redundancy and maintain data integrity. In essence, functional dependencies serve as the building blocks for database design, guiding the organization and management of data within a relational database system. We take an example you have seen on the screen. The given relation R contains attributes A, B, and C, D. Given a relation R, A, B, C, and D, and the functional dependency sets AB determines CD, B determines C, determine whether the given relation R is in 2NF. If not, convert it into 2NF. The answer is to determine if a relation R, A, B, C, D is in second NF, we first ensure it is in first normal form where all attributes are atomic. Then we check if all non-prime key attributes are fully functionally dependent on every candidate key. Given the functional dependencies AB determines CD, B determines C, we find C is the only partially dependent on a subset of a candidate key. From the above arrow diagram, on R, we can see that an attribute AB is not determined by any of the given functional dependencies. Hence, AB will be the integral part of the candidate key, that is, no matter what will be the candidate key and how many will be the candidate key, but all will have compulsory attributes. Thus, to bring R into 2NF, we decompose it into two relations contains attribute BC with functional dependencies B determines C and ABCD relation with a functional dependencies AB determines CD. This ensures both relation meets the criteria of 2NF where each non-prime attributes is fully functionally dependent on its respective relations candidate key. We take also example given a relation R contains attributes A, B, C, D and functional dependency set AB determines CD, B determines C. Find the candidate key, convert the table R, A, B, C to into an F. In simple term, to find the candidate key, we look for the smallest set of attributes that can uniquely identify all other attributes. In this case, AB is the candidate key because it can determine all others attributes CD. So how we will go? So how we will going to do this? First we see functional dependencies. B determines C. Our table was not in 2NF. Let's decompose the table. R1 with attributes BC. Since the key is AB and from the functional dependencies AB determines CD, we can create relation R2 which contains attributes A, B, C, D. But this will again have a problem of partial dependencies B determines C. Hence, R2, A, B, D. Finally, the decomposed table which is in 2NF. Let's take another example to understand it better. In this example, you can see relation R has 8 attributes A, B, C, D, E, F, G. Fields of R contains only atomic values. Functional dependencies are CH determines G, A determines BC, B determines CFH, E determines A, F determines EG. Is a set of functional dependencies so that F plus is exactly the set of functional dependencies that hold for R. So what should be the steps for this? Answer is first we find the closure of A which is A plus is A, B, C, E, F, G, H which is all attributes. Then the closure of B which is B plus is also A, B, C, E, F, G, H which is all attributes. Similarly, E plus is also A, B, C, E, F, G, H which is all attributes except D. F plus is also A, B, C, D, E, F, G, H which is all attributes. F plus is also A, B, C, E, F, G, H which is all attributes except D. So finally, with the help of this closure, we have total 4 candidates key AD, BD, ED and FD. Now we are being take one example. Now we are having one, for example, in which we have given relation R, P, Q, R, S, T, U, V, W, X, and functional dependencies sets PQ determines R, QS determines TU, PS determines VW, and P determines X. And here we have to determine the candidate key of a relation. The answer is from the above arrow diagram on R, we can see that an attribute PQS is not determined by any of a given functional dependencies. Hence, PQS will be the integral part of a candidate key. That is, no matter what will be the candidate key and how many will be the candidate key, but all will have PQS compulsory attributes. Let us calculate the closure of PQS. PQS plus is equal to PQRSTUVWX. PQ plus, let us calculate the closure of PQS. PQS plus PQRSTUXVW from the closure method we find. Since the closure of PQRS contains all the attributes of R, hence PQR. Since the closure of PQS contains all the attributes of R, hence PQS is a candidate key. Now let us understand the types of functional dependencies. In database management system, various types of functional dependencies exist, each serving a specific purpose in database design and normalization. The most common types includes single value dependency, next is multi-value dependency and transitive dependency. Single value dependency is a fundamental concept in functional dependency within database management system. It establishes a relationship between two sets of attributes in a relation such that each value in the determinants uniquely determines a single corresponding value in the dependent attributes. In simpler terms, if two tuples, I mean to say rows, in a relation share the same values for the determinant attributes, they must also have the same value for the dependent attributes. For example, let us consider a table storing employee information with attributes like employee ID and employee name. In this scenario, if the employee ID attributes uniquely identify each employee, then the dependency employee ID determines employee name represent a single value dependency. It means that for every unique employee ID, there exists only one corresponding employee name. Multi-valued dependency. Multi-valued dependency is the type of functional dependency in database management system where a set of attributes functionally determines another set of attributes, but the dependency is on the set of values rather than individual values. In simpler terms, it signifies that for every unique combination of values in one set of attributes, the determinants, there exists a set of rules, there exists a set of values in other set of attributes called dependent. The multi-value dependency is a kind of dependency when one attribute in a database depends on other attributes and has many independent values. It is said to have a multi-value dependency. It supports maintaining data accuracy and managing intricate data iterations. and managing intricate data interactions. Any attributes, say multiple, any attribute, say multiple define other attributes B. Any attribute, say A, multiple defines other attributes B. If any legal relation R from relation R for all pairs of tuples T1 and tuples T in a small r, as you can see on the screen, such that T1 is equal T1 from A is equal to T2, then there exists T3 and T4 in R such that T1A is equal to T2A is equal to T3A and T4A. T1B is equal to T3B, T2B is equal to T4B. It means T1 is equal to T4 and T2 is equal to T3. Unlike single valued dependencies, where each value in the determinant uniquely determines a single corresponding value in the dependent, multi-valued dependencies deal with set of values. This implies that for a given combination of values in the determinant, there can be multiple combination of values in the dependent attributes. Overall, recognizing and managing multi-valued dependency is essential for designing effective and robust database schema that accurately represent the relationships between data entities and support efficient data operations. The last is transitive dependency. A transitive dependency occurs when one attributes or set of attributes functionally determine another attributes through a chain of dependencies. In other words, if A determines B and B determines C, then A indirectly determines C. Transitive dependencies can lead to a data redundancy and anomalies. For example, consider a table where employee determines a department ID and department ID determines department name. In this case, employee ID determines department ID and department ID determines department name, implying that employee ID determines department name transitively. Understanding these types of functional dependencies is crucial for database design, normalization, and ensuring data integrity. By properly identifying and managing these dependencies, database designer can create efficient and robust database schemas that minimize redundancy and support reliable data operation. Joint dependencies. Joint dependencies in database management system represent constraints involving multiple relations, describing the relationships that exist when performing a natural join operation. Unlike traditional functional dependencies, which are confined to a single relation, joint dependencies encompasses relationships between tuples resulting from joining multiple relations together. Formally, a joint dependency asserts that the tuples resulting from a natural join operations between two or more relations can be partitioned into subsets such that the natural join of these subsets precisely reconstruct the original relation instance. For instance, if we consider two relations such as implies, which contains employee ID and employee name, and the department relation, which contains department ID and department name, a joint dependency employee ID Department ID indicates that the tuples resulting from the natural join of these relations can be divided into subsets based on the common values of employee ID and the department ID, preserving the integrity of the join. If the join of R1 and R2 over C is equal to relation R, then we can say that a joint dependency GD exists. In today's lecture, we discuss about the functional dependencies, multivalued and joint dependencies. Now, let's quick back and test your knowledge and check your progress with some questions from today's lecture. Your answer will enhance your concepts as well as make you more aware about the topics. Today's question to test your knowledge are: what is functional dependencies in databases? The next, why are functional dependencies important in database design? What do you mean by multi-value dependencies and explain it? The last is explain joint dependencies in detail. In our exploration today, we have navigated the intricate world of data modeling using the functional dependencies, multi-valued and joint dependencies. In today's lecture, we have discussed functional dependencies, multi-valued and joint dependencies with the help of so many examples. I hope you have learned so many new things today in this lecture, and I wish you to see you in the next lecture. Till then, keep studying. Thank you very much.